This lesson on congruence is really a continuation of the previous lesson. We're going to be doing essentially the same thing. The only difference is that instead of doing it in the coordinate plane, we're now determining congruence in plane space. Those ideas from the first video still hold true. Translations, reflections, rotations, they're all rigid motions that preserve size and angle measure. And anytime we can map one figure onto the other using a sequence of those rigid motions, that size and angle measure is preserved and those figures therefore have to be congruent. All right, so let's just jump right into this. Number 1 says using a transformation or a sequence of transformations, explain why when a transversal crosses parallel lines, the alternate exterior angles that are formed are always congruent to each other. So in other words, what we're trying to do is identify a sequence of rigid motions that will map the alternate exterior angles onto one another. So a sequence of rigid motions that will map angle 1 onto angle 8, could be angle 8 onto angle 1, and angle 2 onto angle 7. That's our goal. All right, I'm going to start by naming a couple of these points. I want to name this point A and this point B. And I'm going to say that if I were to slide or translate angle 1 using vector AB, that's going to map angle 1 onto angle 5. A rotation of 180 degrees about point B is going to then map angle 5 onto 8. So in essence, that is my sequence of rigid motions that will map angle 1 onto angle 8. And I should say that it is one possible sequence of rigid motions that maps angle 1 onto angle 8. I'm going to write these in words just to be a little different. Part of me thinks some of these are a little tricky to write using function notation. So I'm going to say first, translate angle 1 using vector AB. Then rotate that image 180 degrees about point B. This sequence will map angle 1 onto angle 8. I can do something very similar for angles 2 and 7. Using that same vector, translate angle 2 along vector AB. That'll map angle 2 onto angle 6. A 180 degree rotation about point B will again map angle 6 onto angle 7, producing that net result of starting at angle 2 and ending at angle 7. So I'm going to say translate angle 2 using that same vector, vector AB. Then a rotation. And this sequence maps the other pair of alternate exterior angles onto one another. All right, so now I have to have my concluding sentence that says what I did and how come. I'm going to start by saying rigid motions will always preserve size and angle measure. So nothing you haven't heard before. Since there exists a sequence of rigid motions mapping the alternate exterior angles onto one another, they must be congruent. So I'm going to say B/C for because. Perfect. So again, really nothing new in this video. It's still that whole same idea of rigid motions preserving size and angle measure. Now, let me go back and insert the angle there. And the idea that there exists a sequence of those rigid motions that will map the alternate exteriors angles onto one another, causing them to be congruent. All right, let's go take a look at number 2 and see if we can apply that same idea on number 2. They've given us some triangles in this case. They've told us that certain pairs of line segments in those triangles are congruent. So I'm going to start by mapping or marking segment AB congruent to segment XY by putting a little hash mark on each of those. Segments CA and CY, I'm going to put 2 little hash marks on those as an indicator that they are congruent to each other, but not necessarily congruent to the first pair. And then the other piece of information that I'm given here is that those segments XAC and BCY are perpendicular to one another. Or in other words, the place where they intersect makes right angles. My mission, like the first example, is to describe that precise sequence of rigid motions that maps one figure onto the other, causing them to be congruent to each other. So I'm going to go take a look, see if I can find a sequence of rigid motions that'll map one triangle onto the other. I'm going to say it looks like a rotation of 90 degrees or negative 90 degrees because I'm moving in the clockwise direction of triangle BAC is going to map it onto triangle XYC, causing them to be congruent. I could have mapped the bottom triangle onto the top one by using a counterclockwise rotation of 90 degrees, and that would have been every bit as effective. So if that's what you were thinking, know that you're totally on the right track. So I'm going to say a rotation about point C of negative 90 degrees is going to map triangle BAC onto triangle XYC. And as far as why that makes them congruent to one another, well, rigid motions preserve size and angle measure. If your hand is starting to feel a little stiff, know that you're in good company. I'm going to go ahead and flex my finger muscles for a minute before I finish this up. Since there exists a sequence of rigid motions, you could say a rigid motion or a sequence, doesn't matter. Remember, a sequence is one or more than one. Beautiful. All right, and I think that concludes our lesson for today. As always, thank you for the gift of your time. See what you can do with those questions in Delta Math. And as always, if you have questions or need to ask for further clarification, please, please, please ask face-to-face the next time we come back to class. You can ask in an email. You could put a question in Teams. But if you have questions, there are lots and lots and lots of ways to get those questions answered. All right, till we meet again, have fun. We'll see you soon.